A digital communication system transmits a block of n bits. The probability of error in decoding a bit is alpha. The error event of each bit is independent of the error events of the other bits. The received block is declared erroneous if at least one of the bits is decoded wrongly. The probability that the received block is erroneous is, for this question we have been given 4 options out of which one of them is correct. The NPTEL video reference for this question is Module 3 Lecture 23 Probability Foundations for Electrical Engineers by Dr. Krishna Jagannathan, Department of Electrical Engineering, IIT Madras. Some useful information required to solve this question. For a binary symmetric channel, we have equal probabilities of error, that is, the probability that the received bit is 1 given that the transmitted bit is 0 is equals to the probability that the received bit is 0 given the transmitted bit is 1. As can be seen in this case, the probability of error is both equals to alpha, and hence it is an example of a binary symmetric channel. Given in the question is n total number of bits are transmitted. So we consider the case when only one bit is transmitted. It is also given in the question that the probability of error is alpha. So the probability of correct reception of a bit can be written as since correct reception takes place when both inputs and outputs are equal, so this expression has been written accordingly. Let P be the probability that x is equals to 0, then probability that x is equals to 1 becomes 1 minus P. Substituting these probabilities in this expression, we get which gives the probability of correct reception of a bit as 1 minus alpha. Since all the n bits are independently transmitted, the probability of correct reception of n bits is equals to 1 minus alpha raised to the power of n. It is given that the received block is erroneous if at least one of the bit has error, which is simply equals to 1 minus probability that all the n bits are correctly transmitted, which can be written as 1 minus alpha raised to the power of n. So this is the final answer to this question. So the probability that the received block is erroneous is 1 minus alpha raised to n, which is option D.